Do you ever feel down? Like the whole world is weighing on your shoulders? Do you ever look up and you just want to be there in the clouds? Not like dead or anything, but like in a hot air balloon. Yeah, I feel like that too. I only wish I knew how a hot air balloon worked. Buoyancy! Hot air balloons float because they're less dense than the fluid in which they're submerged in. Hold up. What even is density? Density is mass over volume. It's an intensive property. Hold up. What's an intensive property? There are extensive and intensive properties. Extensive properties depend on the size of the system. For example, mass or volume. In these cases, these values are halved if we cut in half the uniform system. Intensive properties, on the other hand, are independent of size, like color, temperature, pressure, or density. But why are hot air balloons less dense than the air surrounding them? That's because when you heat a gas, like we do in a hot air balloon, it expands, silly. Because of that expansion, the same mass will be over a bigger volume. This will then yield a smaller density. We can demonstrate this expansion of gas using the ideal gas law. Air is not an ideal gas, but this law is a good enough approximation to understand the concept of expansion. The ideal gas law goes like this. Pressure times volume is equal to mass times the gas constant times the temperature. Let's try to clean it up a bit. Yeah, that's better. If we isolate the density, represented by variable rho, we see clearly that increasing the temperature, T, gives a smaller density. So now we know why hot air is less dense than cold air. But how exactly does a hot air balloon float? As it turns out, these balloons manage to float thanks to something called buoyancy. As the famous bathtub scientist Archimedes discovered, the buoyancy force exerted on an object is equal in magnitude to the weight of the displaced fluid the object resides in. The displaced fluid is the volume the fluid would occupy if the object wasn't there. This is actually the reason why hot air balloons are so big. The bigger they are, the stronger the buoyancy force. We can analyze a hot air balloon using the ideal gas law again. We can assume the pressure remains relatively constant throughout the flight, making this an isobaric process. The pressure inside and outside the envelope is also roughly the same, therefore we'll just assume it's the same one. The first step in analyzing the hot air balloon would be to find the specific gas constant of air. To do so, we will have to use the following formula. The specific gas constant is equal to the universal gas constant divided by the molecular mass of the gas we need. In this case, air. Having found the specific gas constant of air, and knowing it's the ambient pressure with a chilly of 15 degrees Celsius, we can now find the density of the balloon using the ideal gas law. The air inside the hot air balloon is then heated to approximately 100 degrees Celsius. We then reapply the ideal gas law to find the new density. Knowing the average volume of a hot air balloon is of 2,800 meters cubed, we can then find the mass of the displaced fluid. This will help us find the buoyancy force. We then need to subtract the actual weight of the hot air balloon so that we can find the net force acting on it. And there you have it. Using the ideal gas law, we found the force acting on a hot air balloon, and we now understand how it works.